Printing technologies based on drop-on-demand are known for decades. The drop generation basics and its applicability are extensively studied in the past. Recently, more emphasis has been given in building a single platform device that can be used for different applications. This calls for working on the basics of printing, that is satellite-free drop generation, thicker line prints, larger particle print, etc., which are important to acknowledge. Researchers from Center for Nanoscience and Engineering IEEE-IISc Bangalore developed a new printing technique that generates satellite-free drops and is used for printing thicker lines without clogging the nozzle. The uniqueness of this technique is the use of superhydrophobic mesh for printing, replacing conventional nozzle-based systems.
In drop impact printing, we use the kinetic energy of the impacting drop. So at optimum kinetic energy, a single jet is ejected underneath the mesh from which we get a single droplet. Unlike conventional printers, here we are using a superhydrophobic sheet that is very cheap and also very easy to use. Here, impacting drop, when touches the sheet, eject a single drop and then rebound going back to the recycle unit. In this way, we can recycle the mother drop and again reuse for next run.
The liquid called inks is filled in an ink reservoir and is pumped to syringe through micropipes. The drop generated from syringe from an optimized height was impacted on superhydrophobic mesh to eject a single drop. The drops were collected on substrate kept beneath the mesh. For initial proof of concept, the researchers took water as ink to print through different pore opening meshes, and it was observed that the lowest ejected drop size is 40 microns.
The question is, how does this droplet ejection take place? And more importantly, why does it take place during the recoil phase? Upon further investigation, we found that when the droplet hits the superhydrophobic surface, a cavity is created at its center. And when this cavity collapses, the momentum of the interface is higher than the momentum of the actual impacting droplet. This leads to formation of a jet and which breaks to give us a single droplet.
The research group demonstrated that this technique can potentially and precisely print drops at very high accuracy. This acts as a plus point for applications where accuracy matters a lot.
The main advantage of drop impact printing is here you can use clogging free printing. Unlike conventional printers, here our nozzle does not clog since we are using superhydrophobic sieve. Here we can maintain the resolution and also the thickness in one run. Talking about application, here we have shown printing of biological cells and nanobeads for different applications. Starting from biological cells, we have shown here different cells can be printed in different drops and we can culture it for further applications. Talking about 3D printing, we have shown that we can build a 3D structures of different sizes and it can use for some advanced applications. Regarding the precise and volume control, the technique have very high accuracy. In this way, this technique have lot of advantage compared to the conventional printers.
Researchers suggest that the proposed printing platform can be used for greater number of advanced applications in coming future, such as in pharmaceutical industries for gel-based capsules, for large area lens manufacturing, and many more.